dude. I told you.
All right, welcome out tonight. Thank you for joining us once again. Gentlemen, ladies, everybody else, and coaches, we're live tonight from the Neon Temple. We have a great guest speaker again tonight. Before we get there, what we're talking about coming up next week. It's a holiday. There's nothing going on. Go spend time with somebody you like. Doesn't have to be family, just go find someone and hang out. If you need, a lot of people are doing Friendsgivings. There's a lot of people around. If you're gonna be by yourself, that sucks. Reach out. After that, going into December, first week of December, it is December 1st. The Guild is presenting from the Low Earth Entrepreneurial Center down at the UT, presenting our field of experts for the entrepreneurial program down there, so they can get a chance to talk with some of our experts, see how to help make their company secure and how not to screw up in the security side as they launch new companies down there. A bunch of our members are sitting in the panel. We will be streaming that. If you're interested in coming out live and you're not going to be a heckler, let us know, we can bring you out. For the rest of you, you can find it on the stream just like normal. We have another talk. We're almost certain we have a talk on the 8th. No one can remember what it is right now. 14th, we're ending the year like we've done the past few years with Chris doing another talk for us. So come out for that. That'll be all sorts of fun as usual. Anything else that we need to talk about? Comments from the peanut gallery.
Clean your dang glasses. Okay? I'm not your dishwasher.
Some angry Viking out there is screaming, if you're Ben down in the basement and you haven't been cleaning your glasses, do it. Don't make us do it for you.
Thank you.
All right. So we have a fantastic speaker tonight. If you're out at Defcon30, remember the CTF. Tonight we have Logan Lopez here doing his presentation from Defcon. The CTF was really damn cool. You missed out if you didn't see it there. But hey, if you're listening to me now, you get another shot at it. So without anything else, we're going to pass it over to Logan in just a minute. Go ahead and roll it, Chris.
Logan Lopez, and I'm presenting CANBus, my CANBus, a Defcon30 CTF Postmortem. And so this is CTF, which is SEA, is about an NMEA-based challenge, which is on the next slide. So it was located at Defcon30, and here's the entrance to Defcon30, if you can get that up. So these are the entrances to Defcon30. That was from the bridge and then the main entrance. And here was where the actual CTF competition was, way in the back where nobody else, where like, barely anybody knew about it. So that's why if you didn't know about it, it was very hard to find in the first place. I just found it by wandering around. So here's a good video that introduces this CTF setup, so that you can see. How do I get this started? Oh, there we go. So this shows all the equipment that was loaded up for CTF. That shows a very good example of what we were working with there. It was, that'll be covered on the next slide. Now if I can get my mouse back. Oh, now it's gone again. So what is the CANBus? The CANBus is the controller area network. And it's used in vehicular networks of all kinds. It's not just cars. It's used for boats, as we're talking here, and also for heavy machinery such as tractors. And a great example, so before we used point-to-point linkages, like say, like your throttle was directly linked to your engine, and so when you would push down on the throttle, it would then, cause a valve to open on your engine to then speed it forward. Now we can use packets instead that go back and forth on this CANBus network, and that allows for more integration. So then when you have things like, say, pushing down the throttle, you can have your radio turn up, which is what's used in speed-controlled volume. Okay. And you can usually access the CANBus on your car through the OBD2 port, which is pictured here. And on the bottom there is the basic example of a CANBus message. So how does this relate to boats? So boats use CANBus with a special little flavor on top of it called NMEA 2000 or NMEA 2K, you'll see. And they use what's known as product group numbers that allow it to be plug and play. So you don't have to restart the system anytime you plug in a new peripheral device, which is very useful. And this was an iteration upon NMEA 0183, which had issues when you had different baud rates. So like if you had like slightly older stuff or like slower stuff, it would cause some mismatch issues. And the connectors, it was on one backbone. So like you'll see in the next slide what I'm talking about. And there is a physical definition for the standard, but sometimes the manufacturers like to ignore that and cook up their own thing. And it runs at 250 kilobits per second. I'll just put that on the ground. So here we could see the basic NMEA network on a physical layer. And so as it's just this backbone that you have essentially drops from what they're called T-connectors. And so you have power that comes in every once in a while so that you don't have too much voltage drop. And you have your peripherals that connect in directly. And so they all are chatting over the same line. And that is the anatomy of how one of these inside looks. And this active sense is usually what people will use. These are serial to USB connectors. So this will connect directly into your network so then you can diagnose problems on your boat. So the CTF categories were 4 different categories. There was propulsion, which mainly dealt with the propeller of the thing and also the throttle controls. There was navigation, which was with the rudder. And this was, hello? This one's, okay. This dealt with the moving map, the compass, heading, and even the gyroscopes on the GPS system. And then there was steering, which involved the rudder. And one thing I should mention about the rudder and propeller is that they were both big 3D printed devices. They weren't actual like rudders and propellers that you found on the boat. They were 3D printed for this purpose. And then there was, in this year's competition, there was the ballast, which is that water tank you saw there. And so that is like what helps with the listing of the boat and the balance of it. And all these systems were independent completely. So when you were capturing packets for one, you could not see the other one at the same time. So you couldn't like cheat and get extra data. And also say if you were changing the rudder, it wasn't affecting the heading on the navigation display. And so my previous experience, if you've been to Tampa B-Sides in 2018, they had a vehicle hacking village, and there they used Vehicle Spy mainly. And I did that one with Windows, which is what Vehicle Spy runs on. But you could also use the CAN interfaces that were available on Linux. They were supporting PyCAN as well. And so I didn't do well at that competition. I only got the VIN number. And because of that, I wanted to redeem myself. I always wanted to do another CAN-based competition. And so when I saw this one, I like hit the ground running I really wanted to do it. So our team was me and my friend. So me, I am Logan Lopez. I'm Codex Engineer 2. I run on a Lenovo ThinkPad, you can see right here. And I have previous CANBus experience. And my friend, Cody Campbell, forgot to remove that part, but he's a Codex tech lead. He runs on a MacBook, which is important for later. And he has experience at pointing at objects in GPS-denied environments. And our team name was supposed to be Java Code Clan, which is a name I've used since high school. But I misspelled it on the registration form, so it became GB Code Clan. But then apparently that was too hard for Cody to spell on the actual in-person registration, so he just put Java. So we were just Java. So as you can tell, it was on the poster as well. They had a much better picture of this than mine, but this is the physical station that we were dealing with. And so here we can see the navigation, and and then right next to it is the gyroscope. This little the traffic light looking thing is actually actuated by this. So when this would move, this was lighting up as well. This was the throttle, and there's a secondary throttle on the other side. The wheel was right there, and then the ballast system is behind this guy. And you can see the rudder at the bottom right there. So here is our general approach that we tried with the CTF. So we tried, at first we tried finding as much NMEA 2K resources as we could. And we also tried to quickly get on one of the stations. We registered online, but we didn't know we had to also register in person, which kind of slowed us down because we weren't called to any of the stations first. And we spent a lot of spin-up time trying to get CANBoat working. And Cody, since he was running on his MacBook, he was trying to get Parallels working on it there and getting a whole Linux setup just going. So that was just burning time at the beginning. And you only have 1 hour at each station max. And this is not only to do your research, but it's also to then develop and throw the exploit. So what people would do is they would capture the data, take off and stop their time, digest it, and they would come back later when they have some idea of what they want to throw back. They would try it, and if they don't get it, then it'll go regroup and try again. Or if they start earning flags, and they'll just keep on going until they hit a wall, and then stop the time and go back and figure out the rest. And actually, me and one other team, we made the mistake of just being on the thing the whole time for I did that on the navigation one, and I was just running up the clock. But I figured out what the rule was until near the end. So we actually still had a little bit of time, but the other team just burned through their entire time. So they just spent it all capturing data and trying to figure it out on the clock, so they didn't have time to throw it. And so this was my original vision to try to make something to attack the system that was in play. And so I wanted to make something that you could define like like a little dial, and like it would just like change the rudder or whatever. And I thought it'd be like super cool because I had done one of these before, so I didn't think it would be too hard, and like it would interface with Python. And I knew I had a lot of Qt experience myself, but really, that's not possible. These kind of things, and it's way more complex than you're going to expect. There's a lot of proprietary. There's a lot of proprietary packets at play that aren't really like you're expecting in there, and furthermore, like the documentation is a little sparse, and you'll see why later. And like all those things add up to meaning that you'll spend a lot of time doing this. You're not going to get done doing CTF, and more importantly, like this kind of stuff people sell for good money, and you'll see why. So. So like for capturing, there's a few programs that play here. And so the main one is SocketCAN, which is available on the Linux kernel. It's integrated directly in there. And CANutils, which is just a little thing you add in. It's available on most repos. And CANutils provides CANSend and CANDump, which are very useful commands. CANBoat was one that was suggested by the CTF people themselves. And CANBoat.js is referenced by CANBoat. And they will analyze the CANBoat, the CANBus data from CANDump, and then provide you NMEA messages from there, which are comma separated values, or with CANBoat.js are JSON separated. And pcanview was for their Windows players. So like if you were running on Windows, you could also participate as well with pcanview. And so here was our original pipeline. And so it was using SocketCAN, which sets up the interface. So the interface comes up as a network driver, and you need to set the baud rate, which I think was 15,200 in this case. And it's very good to bring down the interface after you're done using it, because otherwise, if you leave it up and leave the computer running, it just messes things up. So it's nice. Clean up after yourself. And like when you tried, there was some quirk with the CANDump program itself, where like if you try to set a log file name in advance, it will crash it, and that's not documented anywhere. It's not really apparent when you're running it, but just something to note. Then CANDump itself and CANDump2 analyzer will turn those CANDump messages into NMEA messages. And they're more human readable in a way, and it comes out as a CSV file, which makes it easier to use with grep, awk, and sed. So then I could separate out between columns and even filter on certain values within columns to then isolate the messages that I wanted. And so like I even got to the point where I isolated one product group number that I was seeing, and like I was moving the throttle back and forth, and I was seeing it sweep across the different values, which was pretty cool. But in the end, it didn't really help, and you'll see why. So like our progress, like on Friday, we didn't get much. We just were making the stuff work. Again, like Cody was setting up parallels. I was just getting CANBoat to work. And we found it late in the day, so like it closed at 5, and so we got there around 3. So we just spent the time just spinning up. So on Saturday, like we were starting to get cooking because he had parallel set up and I had my stuff set up, and we found like we just decided to switch to pure CANBus. We weren't using any of the CANBoat stuff anymore, and we found better resources to accommodate that. And then on Sunday, that's when we were getting desperate because we just wanted to score some points. And then that's when we ended up getting the propulsion points. That's the only category I was able to score in with the time that we had left. But yeah, it was pretty much all our points were on Sunday. Yeah. And the pivotal moment was like actually on Saturday was when I was trying to get all the CANDump things. I was like always renaming them to be like steering 1, steering 2, but instead I just made like an index file where I just put like the auto-generated name, which is like date and time based, and I put like the description of what I wanted, which made it much more manageable and much easier to sync across with Cody. And so some useful resources is this one website. That's the CAN ID to PGN converter by CSS Electronics. And so when we would isolate the CAN IDs from the basic CAN dump, we could then put it in here and it would tell us exactly what it does. And that was a game changer. That really helped a lot. And also these two, especially this one, the network design, that's where I got most of the graphics for the slides. And it shows just like a basic layout on how the NMEA2K algorithm, not algorithm, but protocol works. And the NMEA 2000 PGNs, the Cypher gave us some other PGNs that weren't available on this one. But yeah. And so CSS Electronics actually does more than just this little thing. This is a demo for a product that they sell, and I'll show you the video for that. And so this is where you'll understand why people pay an arm and a leg for this. So I think the video will play there. There we go. Can we get audio?
Chris,
Audio.
what?
Video.
You want to bring audio up on the TV?
Examples and practical applications within J1939 and OBE2 data logging. A DVC file is a text file that contains information for decoding raw CANBus data to physical values or human-readable form.
Oh,
It is
mine's
today
still live.
the de facto standard for storing CANBus decoding rules. To understand what raw CAN data looks like, consider this CAN frame from a truck. If you have a DVC that contains decoding rules for the CAN ID, you can extract parameters, aka signals, from the data bytes. A signal could be engine speed. To understand how DVC decoding works, we will explain the DVC syntax and provide step-by-step decoding examples. Let's start with a real CAN DVC file example. What you see here is a demo J1939 DVC file that contains decoding rules for speed and engine speed. You can view our full article and copy this information into a text file. Rename it to, in example, J1939.dvc and use it to extract speed and RPM from trucks, tractors, and other heavy-duty vehicles. At the heart of a DVC file are the rules that describe how to decode CAN messages and signals. Each CAN message is described by a CAN ID, name and length, and a variable number of signals. For each signal, the DVC specifies the details required to decode the data. For details, see our full intro article. To understand how DVC decoding works, let's look at how to extract the signal engine speed from the CAN frame that we looked at previously. In practice, most raw CAN data log files contain 20 to 80 unique CAN IDs. As such, the first step is to map each CAN ID to the relevant conversion rules in the DVC file. For 11-bit CAN IDs, you can directly look up the decimal CAN ID in the DVC. For 29-bit CAN IDs, however, the DVC file will contain 32-bit message identifiers, and you will need to apply a mask to match the IDs. Next, use the DVC bit start, length, and endianness to extract the relevant bits from the CAN frame data payload. In this example, the start bit is 24 and the bit length is 16. The engine speed signal is little endian, and we therefore need to reorder the byte sequence from 6813 to 1368. Next, we convert the hex string to decimal and apply the standard linear conversion used in most CAN decoding. As evident, the engine speed physical value is 621 RPM. The previous steps take outset in one CAN frame. In practice, you'll decode raw data with millions of CAN frames, timestamps, several unique CAN IDs, and often hundreds of signals. To handle this, software is used to decode raw CAN data into human-readable form by loading the data log files and the DVC file. The output may be simple CSV files. or, for example, visual plots and dashboards. To understand how DVC decoding works, check out our online DVC editor playground in our full article. Here, you'll also find raw CANBus data samples from a truck and car, including DVC files. The data samples are recorded with the CAN Edge, which lets you log raw CAN data from any CAN-based.
All right, so enough of that ad, but so as you can see, the DVC is what's mainly used for this. And can you guys, so this is a file you can download online, but can you guys give a guess on how much it costs? 45, I hear?
For the file?
For the file.
Not 150.
10, nope, not 10 grand.
42 grand.
200 euros. And that's after you buy the NMEA PGN database, which from NMEA 2K itself, which if you're a non-member, which I'm sure you're all members here, but a non-member would pay $900 for that. A member would pay $600. So you would have to show them the receipt, and then you could pay for the database itself. So obviously, we don't have those kind of resources on my little scrappy team, but we made do without. What? No, we do not, and they just provided us just USB ports on the table. You'll see a little picture of the table later. Yeah, that'd be good. But that'd be a cool Christmas gift. Yeah. But yeah, so the DVCs are essentially the secret sauce to making this work and to understanding it at like the real level that you can decode and like emulate it if you needed to. So we didn't have that. So we made internal tooling instead. And so we did that with Python and just slicing on the basic parts of the text file. Since it was just, CANDump just gives you a timestamp, the interface that is the CANBus, so it would be like CAN0, and then the actual CAN payload. So it would be the CAN ID and the hash, and then the rest of the data. And so Cody made a little Python script that would take, that would just slice for the CAN stuff, get the CAN ID, and would just make a set of those. So that would be a unique list, and then we would make set differences between each CAN capture we did, so we could isolate the CAN IDs that were interesting to us. Because there's a lot of chatter on the network, so they make it very difficult to isolate what you want, which is another complexity to CAN-based CTFs. And so then, what was the basic method that we used was to just take that when we found like some CAN IDs that were useful. We would clean it up. We would then just use, I would use Vim block select, and I would just select out the timestamp and the CAN interface, and I'd just have the raw CAN ID, which then I could then play back in a file with CANsend. CANsend would take that just plain part and would just replay it back over the interface. And I just made a little bash script to do that. And so that was essentially what we did on Sunday. So it was just capture. Like we would capture the data we wanted. So if we wanted to move the thing forward, we would move the propeller forward. I would make sure the time, so I would capture it as it was moving forward. Then I would clean it up and get all the CAN IDs that were necessary. And then I would replay the CAN commands. One important thing you got to note is because we have a 250K bit limit, you can easily saturate the CAN ID. And since you're taking out the timestamps, this is another reason why you can't make such a nice little interface like that. It's because you got to interpolate and rate limit yourself in such a way that like you're not just like saying, okay, turn from here to here within like 3 milliseconds. So that's one important thing is that like when I was sending the commands, I did it at first like that, and I just saw like the system completely glitch on me. And so I added in the sleep, and like at first I made the sleep really generous, and I like made it like 1 second, but then I started seeing other issues. So just that little like traffic light thing you saw there before, I would hear like this because I was sending the command to like actuate it forward, but like every second. So it was like staying neutral. Then it's like, okay, full force forward, and it'll just like like back and forth like that. And like, yeah, I remember they told me to stop doing that because they were worried it was going to damage the stuff. So so it's important to get that right. And the secret sauce that I found was around like 4 milliseconds, they said, was like the sweet spot to keep the packets coming in. And so the main takeaways that we have were like for this kind of competition is that you need to have these values of agility, open-mindedness, emphasis on ground truths, and so I'll go in a little bit into detail on these. So on agility is like just have things ready beforehand. If you are like running on Linux, that's great. Everybody should run on Linux, but if you're running on Windows, have a virtual machine set up. If you're running or Mac, have parallel set up and with a fresh install of Kali or whatever your favorite distro is. And also have some form of synchronization set up beforehand. What we were doing was just like chucking a USB back and forth or like emailing the files to each other, which is very clunky. So other teams I saw, they had like Google Drive set up, so they would just like put in the Google Drive folder, and then like everybody had it at once. Have some kind of synchronized documentation as well. I actually think it's better to do it physically in that case because people are just writing in a notebook and there's like no loss, but like also Google Docs might work or like a wiki if you so choose. But it's just better sometimes to just write things down and be able to sketch out diagrams for different ideas you have, which sometimes doing it text-based or electronically doesn't accommodate well. And open-mindedness, so like trying to get the NMEA analyzer program to do the whole pipeline through like I showed before, that took a long time to get working. And it wasn't giving me any useful data in the end. It just was a rabbit hole I was going down to burn more time that I already didn't have. And I tried to do tricks to capture multiple sensors, but again, since each system was independent, that didn't work. And so I was just doing things that was against my benefit, and it ultimately just wasted time. Also CANDump wasn't working when I specified the file name, like I told you before, in the parameters. So I should have just learned to work with what I had and stop trying to specify the file name and just make an index file that's simple enough and just roll with the punches. And with that, I'd have spent much less time and probably gotten more points. And so emphasis on ground truths. When we were doing our research, we expected certain outputs from the product group numbers that we were receiving. And so we were expecting them to match up with the documentation perfectly. Obviously, that doesn't happen, and I think they do that on purpose. So you need to just look at what's there. You need to what's actually available. So documentation is amazing, but sometimes it's what you're seeing in the moment is what's really golden. Since we try to pre-filter for that, with the data that we're capturing, it was actually we're shooting ourselves in the foot in the end because with these captures we couldn't do anything because we were just capturing junk data of another sensor or some other peripheral instead of the actual data that we wanted. And so being able to just capture more raw data was the next part. So just capture the raw data, and then you can filter and process later. There's always a way to send it in through standard in usually. So just capture the raw CANBus data, or if you're doing another thing, just capture it raw, because as long as you have the hard drive space for it, you can always delete it later or compress it or whatever you need to do. But as long as you have it at first, you can do whatever you need later. At one point, I tried to switch to Windows. So I think because I wasn't getting anything on Linux and I was just trying to do a Hail Mary there. But I think it's important to stay the course because I had to do the whole setup on Windows again. And so again, it's just more setup time. So if you're already running on something and you feel like you're hitting a wall, I think that's probably when you're the closest. So just keep going on that instead of trying to set something else up. With CTFs, time is the most precious thing you have. And so you want to waste the least amount of it as possible. Make a platform decision and stick with it. And so document, just document, anytime you have downtime, if you're installing stuff or anything and you're just waiting for something to finish, just start documenting what you're doing and even just the basic setup commands, because especially at a CTF like Defcon, you're partying, you're tired, you're probably drunk. At least the desert heat will get to you, so you'll forget it. So like if you're going in the next day, you'll be like, oh, what is that CANBus setup I have to do again? You will forget the baud rate, you'll forget everything, and you're just gonna have to ask an idiot all over again. So just document, 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 and it's you think you'll remember it like right after, but you'll get busy on the way home and all that stuff. So it'll escape you before you know it. So just document while you're there. It's really the best way to do it. And so like I've dedicated myself to making write-ups like either while I'm doing CTFs or like right after I do it. So like I'm doing it like when I'm getting a meal or something. And it really helps because then you can make that's what helped me make this presentation right here. And so and just like documentation also in the actual CTF was useful. So, like making an index file again would help us then identify everything without having to rename the files and do a clunky way of like self-documenting that way. So yeah, and also another important thing is bring a mouse. It's like using a trackpad might seem attractive and portable and stuff, but like in these things when you're like having to manage multiple things, especially multiple documents, a mouse really makes you much more versatile. So like a small portable one like this, and make sure like you bring a fresh battery, it makes you go way further in life. And now I need to find my mouse. Okay. So the ballast, that was back to here. So that was only a handful of teams got the ballast system because it wasn't running on the CAN system. So it was a complete different setup that you had to do. That one was mainly running with Wireshark. And you could also capture the CANBus data with Wireshark, but I would highly not recommend doing that because most of the tooling was made to be based with just putting it through like a text file, and either the CSV that you were using with the CANBoat stuff or the actual CAN dump data was pretty much almost used everywhere. And from overhearing what I was just like pestering people that were working on the ballast stuff, I heard that they were crafting packets using Ettercap. So having, again, Kali pre-installed would serve a long way in getting the ballast system going. But those people were very secretive on what they were doing because apparently it was like the very high point area. And so they did not want to reveal their secrets. So I don't know much about the ballast system, but I just know it was one of those things that like people play their cards close to their chest. So here,
I had a question with that. For the ballast system, do you know like if it was still the same sort of packets, they were just analyzing it differently, or was it like something completely different?
It was something completely different. It was not CANBus. It was over like I can't really say. I don't remember. And since I didn't work on it at all, I was working on the other items. So I think that'll be something good to do next year. But yeah, so here is a little demonstration of so see, here's the table that we have, and so everybody has the USB except for the ballast system, then they got like a Ethernet port. And so here's a little demo of.
I think you're good to go. Go for it.
So see the propeller back there that he blocked?
Go for it one more time. Yeah.
And so that was essentially like the first point we got, and I was very proud of that because that it was on Sunday at 2 o'clock and we had 3 hours left.
So you just had to make the thing move or do something?
Yeah.
We spent half a day looking for flags.
Oh, that's rough, buddy.
That's not the point, man. Shush.
So here were the points that we ended up getting. So the one that you saw, the first one you saw was the full steam ahead, and that's putting the throttle full forward. I also did drop the anchor, so that was just spamming the idle command, and so that means that they were locked out at the throttle, that they couldn't move it at all. And whatever works, like I just had Cody move it back and forth and like show it was like just like doing whatever which way we wanted, and that was whatever works, the arbitrary throttle control. And then the buzzer point I got, because I got a point right as it called time, was the other throttle, which there's another one called beep beep beep, and I feel like they misnamed that one because this one actually makes the whole system start beeping like crazy. And so like when it switches to the standby throttle, it'll start going and like so they said like, oh, it's time, and I had hit the command, and so it started doing that, and so that's why they awarded me that last point. And so with that, we ended up getting 12th place. See? Java.
Scroll down to see me. 20th.
And so yeah, that's my presentation. Thank you for coming.
Hell yeah.
RJ had some questions, right?
So RJ's being RJ. So one of our guys is asking if you know what ThinkPad model you have.
I have the T470.
So
Chinese backdoor.
yeah, RJ's just one of our guys is talking about the backdoors and Easter eggs in the ThinkPad models.
Yeah, yeah.
So he's not here, so he doesn't get to give you crap.
I don't know. It works well with Linux. It's very serviceable. Like if I had to replace the smart card in this one, and I replaced my hard drive with the SSD, and you can even put like an NFC module in these as well, and like it's all available online, like the exact part numbers you need. You can buy them from eBay real cheap, and just use a basic fix-it kit. So it's like I think it's much better than like buying a MacBook, which is just as locked down, probably has as many backdoors, and is unserviceable, and doesn't work well with Linux. So you gotta pick your poison somewhere. I mean, System 76, sure, but like I'm not gonna pay double the price for a laptop.
You're not wrong, but if you don't have the money, you don't have the money. That's true.
Yeah, I bought this back when I was in college, so.
So what would you do different for next year?
I think next year, I just start off capturing raw data and then just playing it back and just trying to earn as many points as fast as I can. And just making sure everything's synchronized and categorized early on. And just, again, trying to add to my write-up that I have for this year.
So last year was the first year I went to Defcon, but does this change? They have the CTF every year, but does it change from year to year? Is it pretty,
Yes. So
yeah.
again, they put so it doesn't change too much, but they put the ballast one in this year.
Okay.
And sometimes they switch out CTFs that they have for different things. So I'm hoping that they'll be there next time, but who knows?
So you were mentioning trying to play back packets for points. Do you have paceables or packets reserved? So okay, I send off this packet, the rudder goes right, so I know that this packet does this thing. Did you have those on standby or?
Yeah, so that's what the index file I was talking about before. So we would get the CAN dump of that, and then I would just I would tell Cody to turn it right, and then so I'll get the CAN dump, and then I would put on it's just a text file, and so I just copy in the name. I'd be like, turn right, and so then when I was playing it back, I would just clean up that file and then just put it in a bash script where it would just start reading it, read a line, send it through CAN send, sleep for a few milliseconds, then read the next line and redo it again. So we're actually sending out a bunch of other stuff. You could clean it up a little bit more, but it's just simpler to just send out everything. So any other questions?
Other things, let's see. So, let's see, anything else online? So, nothing on YouTube, RJ's typing, go figure. What are you typing, a Pokemon? Make it happen.
I had recently listened to the Darknet Diaries about Team PPP and how they do the Defcon CTFs. Were they there?
I don't remember. Oh, okay. Yeah.
8, 9 of them were there. Ex, current, and then
that
I
like
joined the Black Parliament.
Is that like DoD?
No, they're just college kids that have been doing it a while. It's like white hatters.
All right, I think that was our last question. Rab, if you have questions, you're standing there. Do you have anything else?
Well, I got like a message from RJ. He didn't want to ask.
But he wants to know. He said, what brand of fedora do you wear when you're doing a CTF?
I don't wear any hats.
Oh, okay. Did you hear that, RJ? Yeah.
So RJ is now trying to get other people to ask his questions. What you got, man? All right. That's it. No, he's just dropping it out. All right, so a great write-up talk and an explanation on CANBus and how to attack the CTF at Defcon. It will be there next time. We'll see what happens in the next event. If you're interested, come play with us. We can do this, all sorts of other stuff. If you've got questions or have ideas for talks that you want to do, reach out. Otherwise, enjoy your Turkey Day next week. Join us in December. Have fun, and we're done.